Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video we'll be discussing other applications of MOSFET. That is, we will be studying MOSFET as a switch so that it can be used in digital electronics as well. Okay. So why do we use MOSFET as a switch basically? I told you when we operate MOSFET in the saturation region, then it is basically acting as an amplifier. So it means if we operate it in the cutoff or the linear region, then we can operate it as a switch. Like in BJT, what did we see? In active region, BJT works as an amplifier. In cutoff and saturation, it works as a switch. Similarly, MOSFET works as an amplifier in saturation region. In cutoff and linear, it will work as a switch. Now, suppose, how do we make a simplest switch? We make it like this. This is the drain voltage, this is the gate voltage, and this is the source voltage. Now when we have a MOSFET like this, I told you off state means cutoff, and what is on state? On state means linear region in a switch. So if we talk about linear region, what is the condition of linear region? The condition of linear region for a NMOS transistor is VGS greater than VT and VDS less than equal to VGS minus VT. Now suppose I have connected two sources. I have connected two sources, one at the drain, other at the gate. And I want to know the source voltage. What I want to know is how to find Vs. Okay. Now we know that VGS is greater than VT. So VG minus Vs is greater than VT. Or you can say Vs is less than equal to Vg minus Vt. So we have obtained a maximum limit on the value of Vs. Similarly, when we talk about linear region, when we draw the output characteristic and we talk about linear region, the characteristics are like this. This is ID versus VDS. This voltage at which the transistor saturates, it is VGS minus VT, and this region is called as your linear region, and this region is your saturation region. It means in linear region the voltage VDS lies between 0 and VGS minus VT. So I can say that the condition VDS greater than equal to 0, what it will say? VD minus VS greater than equal to 0 or Vs less than equal to Vd. So we have obtained two limits on the value of Vs. Either it is less than equal to Vd or it is less than equal to Vg minus Vt. Now if I say both conditions must be satisfied, both condition must be satisfied. So what I will do is, I will take intersection of both the conditions, which will give me Vs should be less than equal to minimum of the two. If Vs is less than equal to the smaller of the two voltages, then Vs is less than both the voltages. This concept is very important from numerical point of view. This kind of question is very common in GATE exam. So remember, the maximum value of source voltage is either equal to Vg minus Vt or it is either equal to Vd. We have to take the smaller of the two values. Okay. So Vs is always less than equal to the smaller of the two values. Now let me show you using an example how do we apply this concept. Now in the circuit shown, the threshold voltage of each NMOS transistor is 0.6. We need to ignore the effect of channel length modulation and body bias, and we have to find Vout1 and Vout2. This is the drain, this is the source, drain, source. So let us focus our attention on the first circuit. In first circuit, suppose this is S1. What I will say, Vs1 is equal to the maximum value of Vs1 is minimum of Vg minus Vt and Vd. What is the gate voltage? Gate voltage is 3, threshold is 0.6, Vd is 3. So minimum of 2.4 and 3. What is the minimum value? 2.4. So the voltage at this point is 2.4. Now this voltage becomes the gate voltage for the second transistor. The source of the first is connected to the second gate. So I will say Vs2 is minimum of Vg. Vg is how much? 2.4 minus 0.6 and 3. So what is the minimum value of these two? It is 2.4 minus 6, or you can say 1.8 volt. So this value is Vout1. That means there are only two answers possible, A and D. Now let us go to the second question or the second circuit. If I talk about Vx, you will say Vx is minimum of gate voltage is 3 minus 0.6, drain voltage is 3. So how much will this become? Minimum of 2.4 and 3 is 2.4. What about Vy? Now this Vx acts as the drain voltage for the second transistor. So Vy will be minimum of gate minus threshold. Gate is at 3 volt minus threshold, and the drain is at Vx. This is 2.4. This is also 2.4. So minimum value is 2.4. What about Vout2? It is minimum of, now this is the gate voltage 3 volt. And what is the drain voltage for the third transistor? It is Vy. Vy is 2.4. So 2.4 and 2.4, the minimum of the two is 2.4. So the answer will be A. So the answer is A, 1.8 and 2.4. So just you have to remember a very simple concept, that the source voltage is the minimum of the two voltage. Which two voltages? Vg minus Vt and the drain voltage Vd. Now let us move to the one of the most important circuit for ECE GATE exam, CMOS inverter. First, let me define what is CMOS. CMOS is complementary metal oxide semiconductor. Now in MOSFET, we know there are two types of MOSFETs existing, PMOS and NMOS. CMOS is made from both type of transistor, that is PMOS and the NMOS transistor. Okay. So CMOS is made up of two types of transistor, PMOS and NMOS. That is why it is called as complementary MOS. Now this technology is used in digital IC to form logic gates. We can form different logic gates like AND gate, OR gate, NOT gate. Everything can be realized using the CMOS devices or the PMOS and the NMOS transistor. But in our analog electronics, we are only studying about one digital circuit, that is the NOT gate, or you can say inverter. So I'll only be talking about one circuit, that is inverter. So how do we realize an inverter using PMOS and NMOS? See, this line is your DC supply VDD. It is connected to the source of PMOS transistor, and this is the gate. Now the drain of PMOS is again connected to the drain of NMOS. NMOS PMOS drains are tied together and the source is grounded. So source of PMOS is connected to VDD, source of NMOS is grounded. Their gate are tied together to the voltage Vin and the drain are tied together to the voltage Vout. We have to understand the operation of this circuit as a step voltage is applied at Vin, or you can say as you vary the voltage Vin. So what we have to do? As Vin is varied, we have to observe the behavior of Vout and the transistors. Suppose this is M1, this is M2. It has a transconductance constant Kp, it will have Kn. Kn is basically mu n Cux by 2 W by L of n, Kp mu p Cux by 2 W by L of PMOS. Okay, I am not assuming that their aspect ratios are same. I am assuming that their aspect ratios are different. So I am dealing with a very general case. Now the gate voltage of both the transistors is equal to Vin, and the source of PMOS is connected to VDD while the source of NMOS is grounded. So let me write down some voltages. What is the gate to source voltage of NMOS? Gate voltage is Vin, source voltage is 0. So it is Vin. What is source to gate voltage of PMOS? The source voltage is VDD, gate voltage is Vin, VDD minus Vin. What about drain to source voltage of NMOS? The drain voltage is Vout and source voltage is 0, Vout. What about drain to source voltage of PMOS? The drain voltage, sorry, it will be VSD actually. The source voltage of PMOS is VDD and drain voltage is Vout. Now why I am writing these voltages is because in order to understand the operating region of the device, we need to know two voltages, VGS and VDS. Okay. Now what is the condition for linear and saturation and the cutoff region? That I will write for both PMOS and NMOS. So when we talk about cutoff, the condition for cutoff region is VGS of NMOS less than VTN or VSG of PMOS is less than mod of VTP. I am assuming that their threshold voltages are different, VTN and VTP. Then what about linear region? For linear region, VGSN is greater than VTN and VDSN is less than VGSN minus VTN. And for PMOS, VSGP greater than mod VTP, VSDP is less than VSGP minus mod VTP. What about saturation? In saturation, the first condition remains same, but the second condition changes. VDSN greater than VGSN minus VTN, and this one VSDP greater than VSGP minus mod VTP. Okay, so that is your condition for saturation. Now what we have to do is we have to analyze the behavior of this circuit under different values of Vin. So let me take the first case, case 1. The case 1 that I am taking is Vin is less than Vtn. This Vtn threshold voltage of NMOS is positive, so that is positive. Okay. Now we know VGS of NMOS is equal to Vin, but I am saying Vin is less than Vtn. That means NMOS is in cutoff. If you have applied a voltage less than threshold voltage, NMOS is in cutoff region. If NMOS is in cutoff region, the drain current is 0, or you can treat it like open circuit. What about the PMOS? For PMOS, VSGP. VSGP was VDD minus Vin. I just explained in the last slide. But VTN, suppose this is, let us take an example. Suppose Vin is 1 volt. Sorry, VTN is 1 volt, so it is 4 volt. Definitely greater than the threshold voltage of PMOS. So PMOS is on. If PMOS is on, it can be replaced by a resistance. So let me show you how you can model this device. PMOS is on, it is replaced by a resistance RP. NMOS is on, off, it is cut off. This is we will not show the gate. We will not show the connection to the gate because there is insulator, but this is V out. Now as you can see that due to open circuit, this current is 0. If this current is 0, what is the voltage drop across RP? It is 0 volt. You can say that V out is equal to VDD. Okay. This voltage is called as VOH. That is high voltage at the output. It is equal to VDD. You can also understand one thing. Both the transistors are connected in series, so their current will be same. Okay. Now, if you draw the characteristic of PMOS output characteristic, it will be like this. Okay. Now the drain current is 0, right? The drain current is 0. In on state, the current can only be 0 at this point. At this point where VSD equal to 0. And that is what I am saying. The drop between source and drain is 0. That is why V out is VDD. You can either go by the output characteristic, or you can do one thing. You can replace the resistance or MOSFET by a resistance and say that since the current is 0, the voltage drop across the resistance is also 0. Otherwise, what you can say? If the current is 0, there is only one possibility, that the source to drain voltage is 0. That is why the voltage at source becomes equal to the voltage at drain, and V out is VDD. You can go by either method. And what is the region of operation in this area? It is linear. So I will say PMOS operates in linear region. So that means in case 1, when Vin is less than Vtn, NMOS operates in the cutoff region and your PMOS operates in the linear region. Or you can say NMOS is off and PMOS is on. Now let us consider the second case. Case number 2. In case number 2, what I will assume is that I have increased the voltage above Vtn, but it is less than the midpoint voltage. Vm is called as midpoint voltage. I will tell you the significance of midpoint voltage later on, but you can understand like this. If both transistors are identical if both are identical, then Vm is basically VDD by 2. So that is why it is called as the midpoint voltage. Now we know for the NMOS, the gate to source voltage is actually Vin, and this Vin is greater than Vtn. So that means NMOS is on. It is on, it means it can be in two regions, either in linear region or in saturation region. It is not in cutoff, that much I can tell, but this condition can lead to two possibilities, either linear region or saturation. Now if we talk about the transfer characteristics of NMOS, the transfer characteristic is nothing but a curve between IDS, ID and VGS. This curve is something like this. It is a parabolic curve. If it is a parabolic curve, after VTN, I have increased the voltage above VTN. So you can say that our operating point will be somewhere here. If it is somewhere here, what I can say? I can say small amount of current ID flows. In previous case, if you see that NMOS was off, so ID was 0. But now I am saying a small amount of current ID will flow. If a small amount of current ID flows, you can also understand it like this. ID is proportional to, in saturation region, ID is proportional to VGS minus VTN square. If this difference is small, that means you have just increased the voltage above VTN, so the current will be small. So I am saying a small amount of current flows. Now just use the same model that we used earlier. VDD, a resistance, and then V out, and then suppose NMOS is on, it is replaced by another resistance. This is the resistance of PMOS, resistance of NMOS. This current ID, I know it is very small. So what you can say, V out is VDD minus ID into RP. So this value will be small because ID is small. So this is less than VDD, or you can say slightly less than VDD. So I know that V out or the output voltage will be slightly less than VDD, but still I don't know about the region of operation of PMOS and NMOS. I only know one thing. What thing I know? That both the transistors are on, V out is slightly less than VDD, but we don't know the exact region of operation, linear or saturation. So suppose I first want to find out the region of operation for NMOS. For NMOS, we have seen that VDSN is equal to V out. This is very high, and it will be greater than VGSN minus VTN. Why I am saying this? See, I told we have just increased the VGS above VTN. Suppose I mean to say it is 2 volt and it is 1 volt. So how much it is? 1 volt. And it is slightly less than VDD. Suppose it is 4 volt. So 4 volt is greater than 1 volt. That means NMOS is in saturation region. Is my point clear to you guys? The value of V out is just less than VDD. It is 4 volt, 4.5 volt, something like that. But VGS is slightly above VT. So their difference is very small. And hence NMOS will be biased in saturation region. So we know region of operation of NMOS. Now what about PMOS? For PMOS, let me delete this. When we talk about PMOS, VSG is VDD minus Vin. Now Vin is slightly above Vtn. Suppose I am taking it as 2 volt. 5 minus 2, it is 3 volt. What about VSD? It is VDD minus Vout. Vout I am taking as 4 volt. So what you will say? VSD is less than VSG minus mod VTP. VSG is 3. Suppose mod VTP is 1. So 1 volt is less than 2 volt. If it is the case, PMOS is operating in linear region. Is my point clear to you? PMOS is still operating in linear region, whereas NMOS has entered saturation. So what is the trend here? In the previous case, PMOS was in linear region and NMOS was in cutoff. So we will say, as input voltage is increased, NMOS moves from cutoff region to saturation region. But this PMOS stays in the linear region. And as Vin is increased, we have seen earlier in previous case output voltage was VDD, and now Vout is slightly less than VDD, which means Vout decreases. So as you increase the input voltage, the output voltage decreases and the NMOS transistor enters the saturation region, whereas the PMOS transistor stays in the linear region. Okay. So let us move on to the third case. In the third case, what I will take is that when input voltage is equal to midpoint voltage. The special thing about midpoint voltage is that when input voltage is at the midpoint voltage, the Vout is also at midpoint voltage. This is a transition point. Okay. It is also called as switching threshold. Also called as switching threshold. It is the point where Vin and Vout both are equal and both are equal to Vm. At this point, both PMOS and NMOS both are in saturation. Always remember, at the midpoint both are in saturation, which means as Vin is increasing, NMOS traveling from cutoff to saturation, whereas PMOS is traveling from linear to saturation, and both are entering the saturation at the midpoint voltage Vm. Now we very well know that the current of both the transistors must be equal. Both are connected in series, right? Both are in series. So you can say that drain current of NMOS should be equal to drain current of PMOS. What is the drain current of NMOS in saturation? Kn VGSN minus VTN whole square. This is Kp VSGP minus mod VTP square. Now we have defined in the first slide that VGSN is Vin minus VTN square. VSGP is actually VDD minus Vin minus mod VTP square. Now just take the square root on both the sides. So you can write Kn by Kp. Vin minus Vin is actually how much? Vm. Vm minus Vtn square. VDD, Vin is Vm minus mod VTP. Okay. This square will be removed. Actually, we have taken square root. Now in order to find out the value of Vm, what we will do? we will combine the terms containing Vn on the left hand side. So Vm, if you take the Vm on the left hand side, it will be under root Kn by Kp. This should be equal to VDD minus mod VTP. Take this term on the right hand side, plus Vtn under root Kn by Kp, which means I can write the midpoint voltage as equal to VDD minus VTP mod VTP plus Vtn root Kn by Kp divided by 1 plus under root Kn by Kp. That is the midpoint voltage. Now see one thing. I told you midpoint voltage is VDD by 2 if both transistors are identical. Let me show you how that is true. If both transistors are identical, you will say that threshold voltage of NMOS is same as the threshold voltage of PMOS, and this Kn is actually equal to Kp. If that is happening, see, under root Kn by Kp will be 1. Under root Kn by Kp will be 1. And these two are equal, so they get cancelled out. It will be VDD by 2. So the midpoint voltage is half of VDD, but that is only when both transistors are identical. Otherwise, we have derived the general expression for Vm, that is VDD minus mod VTP plus Vtn root Kn by Kp whole divided by 1 plus root Kn by Kp. Now I have told that both transistors are in saturation. Let me prove that also. So let me say, let me take an example. Vin is actually equal to Vout, actually equal to VDD by 2, 2.5 volt. Now what is VGSN? It is Vin, it is 2.5. And let me assume that the threshold voltage is 1 volt. And what about VDSN? It is Vout, which is 2.5. It is greater than 2.5 minus 1. That is saturation. What about VSG in PMOS? In PMOS, the source to gate voltage was VDD minus Vin. VDD is 5, Vin is 2.5. It is 2.5 volt. What about VSDP? It is VDD minus Vout. Again 5 minus 2.5, 2.5. So you can say that VSD is greater than VSG minus mod VTP. 2.5 is greater than 2.5 minus 1. Again it is in saturation. So at the midpoint voltage, both transistors lie in the saturation region, and the output and input both are equal to the midpoint voltage. That is the third case where we have input and output as equal. Now let us go to the next case, case number 4. In case number 4, I will increase the input voltage further. So I will say input voltage is greater than Vm, but it is less than VDD minus mod VTP. Okay. Now here we will start from PMOS. Okay, we will first start from PMOS. VSGP. It is VDD minus Vin. Suppose Vm is 2.5 and 5 minus 1, that is 4. So let me take 3 volt. 5 minus 3 equal to 2 volt. Okay. Now that is greater than mod VTP. That is greater than 1. So it is in on state. But again we have two options, either linear or saturation. What about NMOS? VGSN. It was equal to Vin. It is equal to 3 volt. I am taking Vin as 3. It is 3 volt. It is greater than VTN, which is 1 volt. So again NMOS is also on. So again two possibilities, linear and saturation. Now what happens? See, ID in PMOS is proportional to VSGP minus VTP. It is proportional to 2 minus 1 volt. So it will be very small because the difference is small. If the drain current is small, that means NMOS, your NMOS is operating in linear region. Why NMOS is operating in linear region? See this curve, ID versus VDS. So lower currents are obtained in which region? Linear region. So NMOS will operate in linear region. If NMOS is operating in linear region, it is operating as a resistance. In linear region, the device acts as a voltage controlled resistance. So what is the value of Vout? Vout is basically ID into Rn, which is small. If Vout is small, what about VSD of PMOS? The source to drain voltage of PMOS was VDD minus Vout. Vout is small, so the difference is large. If this is large, it will be greater than VSG minus mod VTP. So this PMOS is in saturation. So that means if you go beyond the midpoint voltage, PMOS will enter the saturation and NMOS will operate in the linear region. Okay, I will summarize all these cases later on, but remember, as we go beyond the midpoint voltage, PMOS is in saturation and NMOS is in linear. Now let me discuss the last case. Okay, let me discuss the last case, case number 5. When you increase Vin further, Vin is greater than VDD minus mod VTP, but it is less than VDD. In such a case, what will happen? So suppose VDD is 5 minus 1, 4, and it is less than 5. So let me assume Vin as 4.5 volt. What about VSG of PMOS? It is VDD minus Vin. It is 5 minus 4.5, that is 0.5 volt. It is less than mod VTP. So it is in cutoff mode. If it is in cutoff mode, the drain current of PMOS is 0, but both transistors are in series. So IDN is also 0. So that means your PMOS will be modeled as open circuit. If there is no current flowing in the device, what is Vout? Vout is ID into Rn, that is 0. But we want to know the region of operation of NMOS. For that we need VDS of N, which is Vout, which is 0. So it is less than VGS minus VT. So it will be in linear region. Because VGS is Vin. Vin is how much? 4.5 minus 1, that is 3.5. So it is in linear region and PMOS is in cutoff. So now we have obtained the summary of all the operating region. Let me summarize those regions for you. Okay. So if we summarize the regions that we have obtained for CMOS inverter, Vin. Okay. First of all, the first case was less than VTN. Here PMOS was in linear region and NMOS was in cutoff. Then the next case was greater than VTN but less than VM. Here it was in linear and NMOS was in saturation. The third case was equal to VM. Both are in saturation. Fourth case, greater than VM but less than VDD minus mod VTP. This was in saturation but NMOS was in linear. And the last case, greater than VDD minus mod VTP but less than VDD. It was in cutoff and it was in linear. So NMOS goes from cutoff to linear via saturation. PMOS goes from linear to cutoff via saturation. And if we draw the characteristics, see the characteristics carefully. If we draw the characteristics, that is the transfer characteristics V out versus V in. Initially V out was VDD. So this graph goes something like this. Okay, something like this. So when input voltage is low, output voltage is high. When input voltage is high, output voltage is low. That is why it is called as inverter. This is one of the most important circuits in our electronic circuits, that is the CMOS inverter. When we talk about midpoint voltage, this is your midpoint voltage where input and output both are same. How do we find this voltage graphically? Input and output should be equal. So we draw a straight line, that is V out equal to V in, or you can say Y equal to X. Where it intersects, we will get the value of Vm. This voltage is called as VOH, output high voltage. This is called as VOL. VOH, output voltage in high state. VOL, output voltage in low state. Now on this curve there are 2 points where the slope is -1. This slope is -1. This point is called as VIL. This point is called as VIH. So what I will say, when slope is equal to -1, or you can say dV out by dV in is -1, there are 2 voltages, VIL and VIH. That means VIL is the maximum input voltage to be considered low. Low in digital electronics means logic 0. VIH, minimum input voltage to be considered high, that is logic 1. So what it means in the curve is, up to here, up to VIL, we will consider it as logic 0, and from here onwards we will consider it as logic 1. The middle region is not used in digital electronics. You will either use the input less than VIL or you will use the input greater than VIH, but you will not use the intermediate values. Now when we talk about noise margin is also an important term here. So we define noise margin in 2 states. NMH, it is VOH minus VIH. And what about NML? It is VIL minus VOL. So this is the noise margin, that is the maximum noise that can be tolerated by the circuit without giving the incorrect output. Suppose the desired output was 3 volt, but due to noise it is giving the output as 4 volt. So that means the output is incorrect due to violation of noise margin. And overall noise margin is always taken at the minimum of the two, so that both the margins are satisfied and none of the margins are violated. So overall noise margin is minimum of the two values. Okay. So one thing, if I ask you, if VM increases, what happens? Curve moves towards right. See the curve. If you increase this VM, this curve will move towards right. In that case, VIL and VIH both will increase. But increase in VIH will cause noise margin high to decrease and noise margin low to increase. So basically, if you change the value of VM, you can change the noise margins. Is this curve clear to you? This is the voltage transfer characteristics of a CMOS inverter, and what you need to remember in CMOS inverter, you need to remember these operating regions under different values of Vn. Okay, it is a very important topic from gate point of view, and in the next video I will tell you about how to solve the questions that are based on the CMOS inverter. So this will be all from this lecture. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.